Welcome to the review for our exponential test. Yes, we know that there's some numbering issues. We'll skip 1 through 5, because they're not there. So we'll start with number 6. Tournament. So chess tournament starts with 64 people competing in the exponential function y equals 64 times 1/2 to the x. So it gives us the exponential function. Describe how many people are remaining in the tournament after x rounds, and then how many rounds will pass until 2 people are remaining. So the function describes how many, and basically it's cutting in half every time, and I know that because of my rate right there. So how many rounds will there be with 2 people remaining? So let's take a look. Whoops, wrong page. We don't need this one. We need that one. Okay, so here's my function. All right, 2 people remaining is going to be equal to where we have, okay, this is going to work. 2 people remaining is going to be y equals 2, because that is the number of people, not the number of rounds. And so if I click on here, there are 2 people remaining after round 5. Okay, after round 5. So my answer to that should be 8. All right, number 7. An investment determine how much how much of an investment of $500 if the account earns 8% interest each year for 12 years. Earns. That means we are going up. Okay, so my percent was added to the 100, so I end up with 108%, which means it's 1.08. That's going to be my rate. So y equals the 500 times 1.08 to the x, or specifically, instead of x, I could put in the 12 specifically. Okay, so take a look at that. Okay, I plug it in. I don't even see anything on there, so I could adjust and do, or I can just do specifically with the 12, and we can see that the answer is going to be about 1,259. So when we jump back there, $1,259 is an option. Okay, but writing the equation is going to be one of the main things. 8a, so biology. So again, we have a function here. Here's our function. And so it represents the number of bacteria in a culture after t days. How many will there be after 6 days? So we're looking for specifically where t equals 6. So here's what I have. Okay. I'm going to, at this time, go ahead and, rather than type it in, which I could do, I'm going to say where x equals 6. All right, well, I can't see that, so I'm going to adjust. And my x values, up to 10, that works. I could even say -5, but that's okay. My y values, we're going to go from 0. I'm going to start with 10 and see. Nope, it doesn't look, so I'll add another 0 for 100. No, still doesn't meet. Almost looks like it meets. Oh, now it meets, and I can tell that right there. So I just kept adding zeros until I could see it. And that value is right there. Looks like it is 2,441. So 2,441, which is this one right here. Okay, again, we could, when we type it in, just put a 6 right there. So we could just type in y equals the 10 and 2.5 to the 6, then that would give us our value as well. Now, the question is, what is the domain and range? So our domain, we have our possible x values, our possible days. Well, we can have 0 days and on up. So my domain would be x is greater than or equal to 0. My range, well, we're starting with 10 bacteria in there, because I can tell that from here. So we're starting from 10 bacteria, and then it's growing from there. So we're going to say y is greater than or equal to 10 is going to be my range. All right, jumping back up to the top, number 9. Depreciation. A $60,000 piece of machinery depreciates at a value of a rate at 11% per year. Depreciate. If something is depreciating, it is going downward. Okay. About what will be its value in 5 years. So if I take a look here, if I write my equation, I've got y equals, and if I start out at 60,000, and it depreciates at 11%. So I would take 100 minus 11 to get 89%, which means that I need that as a decimal of 0.89 and to the x. Specifically, we're looking for 5 years. So again, we could just type in that 5 years. So if we take a look at what we have here, I have it to the x value, but I could just change that. So if I redo here, I can just change that to the 5, and that tells me my value right here of 33,504. I could, again, have just found the intersection, but when it just will tell me, I'm okay with that. And looks like our answer is going to be C. Our domain. So we're looking for a domain and range of the same thing. I think it was art. What was it? Yeah, no, it's a piece of machinery. Okay, so my domain, again, number of years. So x is going to be greater than or equal to 0 because we have the amount of 0 years and then on up. And then our range or the value, okay, the value, maybe I should take a look at what my graph looks like. So if I take a look at my graph here, I can't really see anything. So if I do this and change it, let's go up to 30 years. And my y values, I know it's not going to go below 0. And we can go up to, maybe I'm going to put 100,000. Aha. So basically we're looking from here to here. Oh no, that's the 5. So, oh, here's our 0. Okay. It looks like it approaches 0, but it never gets there. So we are between 0 and 60,000. So it is between 0 and that 60,000. And y is in between. It's just going to be less than for that one because it never touches it, but less than or equal to for the 60,000. All right, number 10, what's the domain, range, and asymptote? Well, the asymptote is this imaginary line where it never crosses, and I didn't draw that very well, but y equals -2 will be that asymptote that we need. As far as the domain, we take a look at domain. We have arrows going this way. We have arrows and it going this way. So domain, it would be all real numbers. And then my range, we're looking at just the y value. So it never goes down below here. So my range is stuck, but it does keep going up forever. So it's basically x is greater than 0. It doesn't ever touch that 0, but so it can't be or equal to, but it's going to be just greater than. All right. Mr. Morrison placed an ice pack in the freezer and checked the temperature of the ice pack each hour, and this is what he found after 0, 1, 2, 3 hours. And the temperature is, it starts out at 73. It looks like it's going down 50.4, 36.3, 26.1. What exponential function models this table? And at this rate, what will his ice pack reach below 5 degrees? So if we take a look, we have a table. And so if I input my table here, I've got my stuff going on here. I can't see anything, so I guess I better adjust this again. Probably my X is pretty good. Maybe I can go out to 20. I definitely don't need -10 hours, so we'll start with 0. We're going to go from 0, it being our lowest, up to, looks like 73. So I'm going to go just up to 100, and then I can kind of adjust what I have going on here. We can write our equation. We can have Desmos write our equation. Remember, it's that y1 squiggle, a, b to the x1. And it draws it for us. And then it tells us our parameters. It says a is 72.59, and our b is 0.706. So taking a look at this, if I look at my chart here, it's saying 0 is 73, and if we round that, that would end up being that 73. So there's our amount of going on there. If we round this one, we would end up with 0.71. If it was multiple choice, you might see actually 0.70. It just kind of depends. So if we take a look, the exponential function, we've got y equals, we're going to start with 73. And I'm going to go ahead and put 0.71 to the x. Okay, so that would be our equation. And then it says below 5 degrees. So below 5 degrees means that we have to have y equals 5. And when we do that, here's our point for that. And it looks like it was 7.698, or excuse me, 696 hours. So it would be good to just go ahead and say after at 8 hours. Okay, it's really between 7 and 8 hours. It's during the 7th hour, but it will happen for sure at the during 8 hours. Okay. All right. So I'm going to wrap up page 1 here. So this will be part 1, and we'll do part 2 in just a